2007, number 6, but I'm only going to do parts A through C. We start off with the known series e to the x, and then we want to write the first 4 non-zero terms and the general term for f of x, which is going to be found by substituting negative x squared into every x. So when I prep for substitution, I leave a parentheses for every x, and now let's plug that in. And then simplify. When I square my negative, it goes away. When I cube my negative, it stays. And I multiply my exponents when it is base to a power to a power. For the general term, I separate the -1 multiplication, and then x to the 2 to the n is x to the 2 times n. And that is now my e to the negative x squared, which is being represented, it is being named as f of x. So that is part A. Part B, I want to subtract this function from 1 minus x squared. So what's going to happen is I'm going to have, come up in, I'm going to have 1 minus 1, negative x squared minus negative x squared, and then a subtraction of all of these. And this is now my numerator, that is 1 minus x squared minus f of x. Then when I divide that by x to the 4th, I will have negative 1 over 2 factorial plus, and then x to the 6th divided by x to the 4th will leave me with x squared. And if I'm dividing by x to the 4th, the elimination of the first couple of terms will not affect the general formula that begins a little bit later. And I have the multiplication by -1 already in there. If I divide by x to the 4th, I am subtracting 4 from the exponent. Okay. And now I am being asked to use the answer in part A to find this limit as x approaches 0. So now limit as x approaches 0. When I plug 0 into every single x, I will end up getting just -1/2, because 2 factorial is 2. And that was letter B. Then for 2007, letter C, we are going to take the function that we had gotten in part A, and for the sake of being able to solve a definite integral that involves the variable x as a limit, I need to use a t variable instead of the x variable that I'm using for f of x. And I'm going to integrate from the center to the x variable. Since the center is 0, then technically when I'm integrating from the center to x, I'm just integrating in a normal way, but no plus c. So I'm going to erase the work from part B, so that is not in the way. And then I'm going to start here, and I'm just going to integrate that And with the center being 0, when I integrate the constant, I will do the normal integration. I always, though, want to do x minus the center. Center is 0, so I'm not bothering with a minus. And then integrating, I have my negative sign and then x cubed over 3. Integrating, my negative sign got squared away. I actually had x to the 4th. I suppose I got rid of my simplified version, didn't I? And so I have 1 over 2 factorial times the integral of x to the 4th, which would be x to the 5th over 5. For this one, the cubed kept the negative sign, and I had x to the 6th. So integrating to get x to the 7th over 7. And before integrating, I simplify and separate -1 to the n, and I have x to the 2n. And when I integrate x to the 2n, I will get x to the 2n plus 1 over 2n plus 1. So that is the integral from 0 to x. And it's asking me for the first 4 non-zero terms, so I did more than I needed to, which means if I were on an AP test, I should probably get rid of the stuff it did not ask for. So 4 terms, 1, 2, 3, 4, and squiggly equal. It's wanting me to then use only the first 2 terms to estimate the integral from 0 to 1/2. So I am going to take my first 2 terms and just plug in 1/2 because that's the x. And if I want to simplify that a little bit, that's 1/8. 8 times 3 is 24. And I can go further, but that is sufficient. And then I'm not going on to part D.